All right, so this one goes with number 3 for our Unit 4 stations review. I just went ahead and wrote out the equation because it's asking you for is to solve for x. All right, that's essentially all it's asking. So, like I always say, let's see if we can solve anything inside the parentheses. Can we? No, you cannot combine variables with constants. Therefore, we need to distribute. You are distributing this half to everything inside the parentheses. So it is 1/2 times x. Well, that would be 1/2 x. All right, well, what is 1/2 times -4? Or guys, read it as, what is half of -4? -2. That's going to equal 3 over 2x and a positive 5, because we can't combine these two. So we've officially gotten it down on both sides where we have variable and constant, variable and constant. So we now need to combine our variables on one side, or get our variables on one side and our constants on the other. In order to do that, you have to do the opposite of one of them. Well, I'm going to start with this -1/2 x. And I have to do the opposite of this to the other side. But a lot of us don't like working with fractions. So it's important to know, well, that half, or 1/2 in decimal form is 0.5. 3/2 in decimal form is 1.5. So technically, you could have it written exactly like this. All right? This works just as well. So I wanted to move my variables first, so I'm going to subtract 0.5x from both sides. All right, so they'll cancel on the left, and you'll be left with -2 equals, well, a positive 1.5x and a negative 0.5x is just going to give you 1, guys. If you want to put that 1 in front of it, you can, but you need to get in the habit of understanding that an x, or a variable by itself, technically has a 1 in front of it. Now I'm going to bring down this positive 5. Okay? We have constant by itself on this left side, so let's move the only other constant to be with it. You have to do the opposite of a positive 5, which is a -5 to both sides. Bring down this x, because it's not being used. And what is a -2 and a -5 equal? It's going to equal a -7. And it's a -7 because you have to follow your integer rules. If you have the same sign, you're going to add and keep the sign. All right, so you added them and you kept the negative sign. So for number 3, you should have gotten x equals -7. Okay. Let's look at number 4. Number 4. It says, what value of x solves the equation? So it has this big equation. Record the answer in decimal form. All right, so let's just solve it as normal. So let's just solve for x as normal. Then we can worry about the decimal, getting it into decimal form. So I'm just going to copy this down. And if you're following along and working with me, you're more than welcome to pause it, get it written down, and then follow along instead of just copying it down and not understanding it. But let's solve for x. Can we solve anything in parentheses? Nope. So we need to distribute. Well, 4 times 2x is going to get you 8x. 4 times -3 is going to get you a -12. Equals, well, a -3 times a +3 is going to get you a -9. And a -3 times a -4 is going to get you a +12x. All right? We have variables and constants on both sides. So we need to get our variables in the same room and our constants in the same room. It does not matter which one you move first. In this case, I'm going to move my -8 first, though. Sorry, it's a +8, but in order to move it, it would be a -8x. And you can only put your variables with the same variables. So that's why the -8x is going with the 12x. Those cancel. Let's bring down the -12. Equals, well, we haven't used this -9, but now we need to solve. What's a +12x and a -8x? Well, that is a +4x. All right, so we're getting places, but we need to get our variables completely by themselves on one side and our constants by themselves on the other side. The constants right here is already by itself, so let's move this negative 9. In order to move the negative 9, you have to do the opposite to both sides, which is a positive 9, because we need those to cancel. You'll just be left with 4x equals, well, a negative 12 and a positive 9 is going to get you a negative 3. Following integer rules. They are different signs, so you subtract, and you keep the sign of the larger number. In this case, the larger number is 12, and there's a negative with the 12. So we're finally at our last step. Okay, at our last step, we have to break up our coefficient and our variable. In order to break them up, you need to divide both sides by the coefficient, because that will leave you with 1, so you're just left with x, and negative 3 divided by 4. If you were to put it in a calculator, or if you were just to know what 3/4 was, you would get negative 0.75 as your final answer. Because, remember, number 4, it wanted you to record the answer in decimal form. All right, so you should have gotten negative 0.75. All right, looking at number 5. Looking at number 5. What is the solution to the equation? It gives us a big, pretty equation, and it wants you to pick what the solution is. So you have 3 over 2. Well, we also know that that's 1.5, guys, if you want to put it like that. X and negative 3, positive 2x, and a negative 5 equals 8. Looking at this, okay, I don't want you all to get confused if there's literally only one thing on the other side, or one number, one variable, whatever, on one side of the equation line, like that. Don't let that freak you out. Your main objective is to still get your constants on one side and your variables on the other side to do your last step. But before we even worry about moving anything, let's distribute, because we can't combine these. So you need to distribute this 3/2 times x, which would give you 3/2 x. Then you would need to do 3/2 times negative 3. But give me a second, I gotta go let my dog in. Okay, so you need to do 3.5 times, or sorry, it's 3/2 times negative 3. Well, we already know that 3/2 is the same as 1.5. So, well, 1.5 times a negative 3 is going to get you a negative 4.5. All right, if you were to plug that into a calculator, guys, if you were to put it in decimal form, so you have 3/2, which is 1.5, times 3 gets you 4.5, but it's a negative. All right? Plus 2x and a negative 5 equals 8. Now, we need to see if we can combine anything before we try to move anything to other sides. Well, can we combine anything on this left side? Yes, you should be saying yes if you're following along. You can combine the same variables with the same variables. So again, this is technically 1.5x. If we were to combine 1.5x with a 2x, we would get 3.5x. Okay? If you were to combine a negative 4.5 and a negative 5, well, guys, you have the same sign, so you're adding and keep the sign. You would get a negative 9.5. All right? And that's going to equal 8. So we've officially gotten it down to where we just have one set of variables, one set of constants equals some constants. So now you need to get all your constants on the same sides. So you're going to get plus 9.5 on both sides because you have to do the opposite. You'll be left with 3.5x equals, well, if you guys need to do it on a calculator, you have access to a calculator, but you would have 8 plus 9.5, which would equal 17.5. And we're at our last step now. We have to break up our coefficient and our variable. And in order to do that, you have to divide by the coefficient. So you would do 17.5 divided by 3.5, and that would get you 5. So your final answer would be x equals 5. And in this case, 5 would be A. All right? Because x equals 5. All right, looking at number 6. So this one's kind of lengthy. So I'm going to go over 6 with you all for the last part of today's video. And then I'll continue the rest of this tomorrow so it can be more review for your interim assessment coming up. But looking at this one, you have a teacher writes 4 equations on the board. And this table shows the 4 equations. Your goal is to find which equation has an infinite number of solutions. Guys, do not let infinite number of solutions mess you up. This is the same thing as all solutions, okay? Infinitely many is the same as all solutions. So what you're needing to do is break these down as far as you can to where you have it in this setup. You have a variable and a constant equaling a variable and a constant. All right, because we need to figure out which one of these has an infinite number of solutions. This one's broken down enough already for us to determine that this will have one solution because you have different variables on both sides. But we don't know if equation 2 will have infinitely many solutions yet. So, well, let's work it out. You have a negative 3x, a positive 5, equals negative 3, in parentheses, x and a positive 2 plus 17. All right, so we need to break this down, or this side down at least, to see if it will equal negative 3x and a positive 5. All right, so in order to break it down, we need to distribute this negative 3 to everything inside the parentheses. What is negative 3 times x? Well, you'll get negative 3x. All right, negative 3 times a positive 2 is a negative 6. Let's bring down this positive 17. All right, and then we'll bring down this negative 3x and positive 5 because we haven't touched it yet. Well, looking at the right side, can it continue to be broken down further? Yes, it could. Because you can combine these two constants. You have a negative 6 and a positive 17. All right? A negative 6 and a positive 17 is going to get you a positive 11. Bring down this negative 3x, and then you're also going to bring down what was not used on the left side. So now you're left with a variable and a constant, a variable and a constant. Just looking at this, we should be able to determine if we will have all solutions, no solutions, or one solution. All right? Looking at this, in order for there to be all solutions, you would have to have the exact same thing on both sides. Do you? No, you don't. Yeah, you have the same variables, but you have different constants. Therefore, this one would be no solutions. All right? No solutions would go with equation 2 that they're having us try out. All right, so we've immediately eliminated equation 1 and equation 2. Neither of those work. So let's try equation 3 to see if it will be infinitely many solutions. So you'll have 2 in parentheses 3x and a negative 5 and negative 3 equals x and a positive 5. This is a very long equation. X and a positive 5, and then x negative 1, negative 8. All right, so this is equation 3. We need to break it down to where we get a variable and a constant equaling a variable and a constant. In doing that, we'll be able to determine if there's all or infinitely many solutions, no solutions, or 1. You cannot combine anything inside these parentheses, so you need to distribute. 2 times 3x will get you 6x. 2 times a negative 5 will get you a negative 10. Bring down this negative 3 because we haven't used it. Equals, well, let's bring down this x because this positive 5 is what's going to be multiplied to everything inside the parentheses. Well, positive 5 times x is going to get you a positive 5x. Positive 5 times negative 1 is going to get you a negative 5 because remember, we have to follow our integer rules. And now we're going to bring down this negative 8. You're bringing down the negative 8. If it is not inside parentheses, you are not multiplying it by 5. It has to be inside the parentheses to be multiplied. It's not, so you just bring it down. Let's see if we can combine anything. All right, let's see if we can combine anything on the left sides or the right sides. Looking at the left side, you can combine constants with constants. All right, so you have a negative 10 and a negative 3. Well, they are the same sign, so you add those and you keep the sign that they have, which is a negative. Bring down this 6x. This side, nothing can be combined anymore. Well, let's see if we can combine things on the right side. Well, if we've been paying attention, we should be able to. Here you have a negative 5 and a negative 8. All right, that's going to get you your constants. All right, well, a negative 5 and a negative 8 is going to get you a negative 13. And then you also have 2 of the same variables. So you can add those together as well, or you can combine those. You have a positive x and a positive 5x. That is going to get you 6x. All right, let's see, or you should be able to see that they are the exact same on both sides. You have the same exact variables. Both are positive 6x's, and you have the same exact constants. Both are negative 13s. Therefore, your final answer would be, I misspelled infinitely. This would be all solutions or infinitely many, and that's what number 6 was asking for. Which equation has an infinite number of solutions? Well, we just broke down equation 3 and found that it had all or infinitely many solutions. Therefore, your answer to number 6 would be equation 3. All right, so I'm going to stop it right there. We went through 1 through 6. I'm going to go through 7 through 14 tomorrow because we'll be doing some more review tomorrow during class as well. So bear with me, guys. We'll get through it, and you guys are going to do good on these tests.